Hello everyone, we are Group 15. The topic we are going to discuss today is how does enterprise architecture help the manufacturing industry through digital transformation? Many manufacturing companies are pursuing digital transformation. In fact, an estimate 900 billion waste. This shows that 70% of digital transformation fail to achieve their goals. The reason that the digital transformation fail might include, in some cases, the company didn't realize digital transformation is not only about technology, but is a relative, dynamic, and continuous evaluation that take place at different layer of enterprise architecture, like bringing information system strategy into alignment with business strategies. Meanwhile, traditional manufacturing enterprise like P&G and Ford are challenged by Tesla, the emerging startup 20 years ago, which successfully implemented digital transformation by technology, cloud computing, and iOS. Therefore, we will discuss the issue. How does enterprise architecture help the manufacturing industry through the digital transformation? Let's look at the overall strategy for enterprise architecture. And the overall strategy of enterprise architecture reconstruction is based on the four layers of enterprise architecture to give the roadmap, which including business architecture, application architecture, and data architecture and technology architecture. The TOGAF framework refers to the business layer of enterprise architecture. The architecture development method, and it's called the ADM, is the core process for create the TOGAF framework and concept of the inception phase, preliminary phase, and phase A to H usually uh, performed squarely, but some step may be left for interaction and the eight phases of the target framework provide a property get get for a new enterprise architecture to help organization analyze more creative. The digital transformation of the manufacturing industry applied in the paper is divided into three steps. The first step is per managing per management, which refers to current situation of manufacturing industry and it relate enterprise architecture implementation plan. And the next step is to identify the current business and technological architecture of uh, certain manufacturing in the industry. And finally, the technology architecture of phase D will focus on the Internet of Things and cloud computing to help manufacturing companies achieve digital transformation.
Then I would like to discuss the IT layer of enterprise architecture, specifically focusing on the application of cloud computing. According to the Mayor and Garris, the cloud computing enables to ubiquitous, convenient on-demand network access to a shared pool of computing resources. It can be republished, professional, and released with minimal management effort on service provider integration. This definition aligns well with the needs of traditional manufacturing enterprise, which can leverage cloud computing to design an IT schema that aligns with the IT layer of enterprise architecture. We have major cloud service providers such as Amazon, Alibaba, IBM, and others. This industry giants has a strong dominance in the cloud computing sector, which ensures the success of adopting cloud computing architecture in the manufacturing industry. Let's now delve into potential benefits of cloud computing for the manufacturing industry by this table. However, the details focus on different layers of IT layer in the enterprise architecture we'll talk about later. We have the technique application and the data layer. Starting with the technical layer, infrastructure as a service and platform as a service are suitable for integrating technology into enterprise architecture. By leveraging this service, traditional manufacturing enterprise can reduce their reliance on exciting IT resource and achieve better technological integration. Moving on to the application layer, software as a service plays an important role in daily operations. It can transform business process and artifacts into application service, offering benefits such as reducing architecture redundancy, ensuring consistency, and providing agility. These advantages are vital for efficient and effective operations with the enterprise. Lastly, in the data layer, both SaaS and PaaS are suitable for building a standard, unified, and shared data platform. This approach creates a scale and reliable storage environment for the traditional manufacturing industry, facilitating strategic decision-making. In conclusion, cloud computing provides enhanced opportunities for traditional manufacturing enterprise to enhance their IT layer within the enterprise architecture.
Another IT architecture appliance in manufacturing industry in this paper will be Internet of Things, which refers to interconnected appliances including terminals, executors, sensors, and transmitters connect to the internet to monitor and control every equipment in the manufacturing process. It is suggested that five-layer IoT architecture applying in the manufacturing industry. Business layer refers to the design methodology of the whole IoT system. Application layer will be any terminals and devices that connect equipment through network. Communication layer will be the interconnection that support multiple protocol between terminals and equipment. Then process layer refers to analysis layer with the data collected from perception layer. Finally, perception layer refers to the physical layer. Any sensor executors equipped in the manufacturing devices. To deeply understand the methodology in this paper, the case analysis of Ford and P&G will be introduced. These two companies has experienced the failure of digital transformation, but through applying cloud computing and industrial IoTs, successfully achieved their digitalization goal. Ford directly set up a new segment for the smart mobility to build digital-enabled vehicles, which leads to low level of integration with existing segments of the organization. In 2021, Ford has partnered with Google to get cloud computing services, which provide Ford architectural direction for manufacturing companies and achieve the Ford targeted enterprise architecture. In 2012, P&G was eager to be the most digitalized manufacturing companies in the industry and directly invest lots of budget in digital transformation by misidentifying, targeting the price architecture, and ignoring external economic conditions. The partnership between P&G and Microsoft was formed in 2022. P&G has applied an Azure IoT Hub and Azure IoT Edge to collect data from sensors in the production line, then monitor any potential problems in the production line and predict the manufacturing process to adjust the customer demand, which dramatically increased the operation efficiency and limited the resource base.
For the challenges and limitation, although using the TOGAF ADM framework and combining IoT and cloud computing technology to help traditional manufacturing companies carry out digital transformation will bring many benefits, there are still many challenges. The first challenge is uncertainty and long payback period. Firstly, the technology and equipment of many traditional manufacturing companies are outdated, so they need to invest a lot of money to reconstructing their IT infrastructure. And it is time-consuming to redesign business process with TOGAF, which may influence the company's daily operations. Secondly, many large companies have invested heavily in digital transformation, but the returns have not been sufficient and quick enough to offset the loss. Therefore, they need to make long-term plan and accept the risk during the period to avoid performance challenge and shareholder obligation. The second challenge is information security and privacy issue. Firstly, cloud-native computing heavily relies on the cloud-based data storage and processing, which means sensitive manufacturing data will be transferred outside the company's internal network, resulting in limited control over the data security. Therefore, if cloud providers do not provide strong enough protection measurements, a large number of private data include protection information and business secrets will be leaked. Secondly, an increasing number of devices connect to the internet in the manufacturing companies means there are higher chance of cyber attacks during the production. Additionally, since resource on the perception layers is limited, cybersecurity machines that require lots of computing power are not suitable for the IoTs like IDS, as lead to system defects that cannot be fixed in time. The third challenge is the limitation of TOGAF ADM framework. While the TOGAF ADM framework can provide strong theoretical guidance for the enterprise in digital transformation, but its role in practical application is very limited. Manufacturing companies need IT professionals to implement customized designs and theoretical adaptations based on the TOGAF ADM framework that corresponds to the actual situation. And the IT and business departments may face misalignment when adopting the TOGAF ADM framework. While the framework provides guidance on the overall objective, it lacks specific implementation details, which can result in inconsistent and confusion during the implementation process. And for the small and medium-sized companies that lack sufficient resources, TOGAF ADM is too complicated.
Hi guys, to address the above challenges, 3 recommendations are proposed. These recommendations are used to help traditional manufacturing enterprises successfully complete their digital transformation. The first recommendation is implementation of two-speed architecture with cloud computing. To address the high cost of digital transformation in traditional manufacturing, enterprises can better balance resources and enable digital transformation by combining a two-speed architecture with cloud computing. Establishing a two-speed architecture practice can help organizations determine priorities and achieve a rational allocation of resources. An agile method is also used to drive rapid iteration and project delivery. In addition, by deploying an innovation layer on the cloud, organizations can design and implement new systems and applications faster, while maintaining agility and flexibility. The second recommendation is novel solution for information security and privacy. First, designing secure storage services as a public cloud infrastructure and using cryptography for analysis can effectively protect data privacy and data confidentiality. Then, strict level-based access control policies are implemented to restrict access to and processing of sensitive data. Data security can also be improved through cryptographic analysis to evaluate the strength of encryption algorithms and security measures. In addition, set up the necessary security measures to protect data privacy and confidentiality before deploying IoT devices to ensure the security of the network. The last recommendation is the customized TOGAF ADM framework. TOGAF ADM describes the process of creating and implementing an enterprise architecture to guide the work of enterprise architects. However, in practice, enterprises often need to customize the TOGAF ADM framework to meet their specific needs for digital transformation based on their own state and requirements. Enterprises are required to consider their existing IT architecture to ensure the integration of digital transformation with their architecture. Therefore, enterprises are required to prioritize their core business and key issues in digital transformation to effectively address existing business challenges and improve business efficiency and competitiveness. That's all about the presentation. Thank you.